global warming. And whenever I present now some data, I will only quote scientific work that has been published in international journals and that was peer-reviewed, how is it called? Is there a climate change? Does the climate change? Yes, you have seen on the title, I explain why it changes. Is there a greenhouse effect? Yes, there is a greenhouse effect, but actually, you see the word greenhouse is in quotes, it's not the effect that is utilized in greenhouses, in glasshouses. I will explain in detail what is the difference. And is CO2 a greenhouse gas? Greenhouse again in quotes. Yes, it is a greenhouse gas. We hear about global heating, it becomes hotter and hotter. Again, we have to ask, really? Let's look at the international homepage of Statista, at this graphics. And they have the headline, all-time temperature records, all-time cold temperature records. So that means in these countries, the lowest temperature that had ever been recorded in history of recording temperatures was recorded. And when was that? In 2023, in January, they recorded the lowest temperatures ever. That means over a time span of roughly 150 to 180 years. And also in the United States, this is a headline from a newspaper, coldest ever US temperatures. And when was this headline? It was February of this year. And now to the crucial question, the relation between CO2 and warming. What we are told is when CO2 increases, then the warming adds up. And let's look at the data again. I have shown you this curve already. This is from these ice core drills. We see these fluctuations. And now, as I told you, from the air bubbles inside the ice cores, we can also get information how much CO2 was in the atmosphere over this time span. Here I give you again this relation, 100 ppm is 0.01%. You see, that's the reason why we don't use a percentage as a number, but the ppm. And this is the data. And if you make a short glance at it, you can say, oh yes, we see very clearly the CO2 is rising, temperature is rising, CO2 is rising, it's going down. There's a strong relation between CO2 and temperature. But you have to look very carefully. Look at these lines here. The blue line is starting first, it goes up, and then the CO2 follows afterwards. And this has been subject to many research works, and they've looked into detail into these curves. Here you see the temperature from this peak at around 235,000 years ago. And here you see the CO2 curve. And here you see it already clearly. First the temperature goes up, and then CO2 starts. CO2 goes down, temperature goes down, not so in correlation. There are other effects that it does not go down so drastically, but here you see it very clearly. First the temperature goes up, and then the CO2. Global temperatures are falling since 2016, not rising. This is official data from the Hartmut 5 temperature data set. So, this greenhouse effect is caused by these greenhouse gases, like they are called. So what is a greenhouse gas? Which property makes a gas a greenhouse gas? And it must have the following property. It must let through visible light, more or less all of it, and it must absorb this infrared radiation, this thermal radiation going to space. And nitrogen does not do that. Nitrogen does not absorb infrared, therefore nitrogen is not a greenhouse gas. And also oxygen doesn't do that, it's also not a greenhouse gas. And also argon does not do this. So it's actually these trace gases that make this greenhouse effect because they absorb the infrared. The greenhouse gases are water vapor, carbon dioxide, methane, and nitric oxide. And the effect is very strong. We have seen 330 watt per square meter is this back radiation. With the greenhouse gases, we have an average temperature of 15 degrees, plus 15 degrees Celsius, all averaged over the whole surface of the Earth. Without the greenhouse gases, we would have minus 18 degrees Celsius. So there would be no life on Earth because everything would be frozen over. The effect is very strong. It's 33 degrees Celsius. And the greenhouse effect is the most important factor determining the global temperature, determining climate. The most important contribution. And now we look into this absorption of the infrared even in more detail in order to understand really the greenhouse effect. Here we have a volume of gas and we have a light beam going through, and we see it becomes weaker and weaker because of the interaction of the light with the molecules. The molecules, they suck away some energy from the light beam, it becomes weaker, and this is transferred into heat. So around the light beam we have something like a cylinder of warmed up air, and you see the warming decreases because the light intensity also increases, because what is transferred into heat here is missing on the light beam here. Therefore further down, not so much energy is in the light beam, not so much can contribute to heating. And now we look at a certain gas. And what we find out when we look at which wavelengths is this interaction working, we see there are only very small areas where the light can interact with the gas, and these areas where this is happening are called peaks, absorption peaks, and this is now called an absorption spectrum. We will see at which wavelengths is interaction between the light and the gas, and these peaks, this arrangement of the peaks is typically for each different gas type. So this is different for nitrogen and oxygen and water vapor and so on. And what we show here is how much light is absorbed, that is converted into heat, and is missing from the original light peak, and for sure the limit is 100%. More than 100% cannot be absorbed inside this tube up to heating. This is CO2, and you see there are also, this is a very broad band, but saturated, completely saturated. Here this is saturated, and there are some smaller peaks, some very narrow peaks that are not saturated yet. And this is water vapor. At the current concentration of water vapor, and you see water absorbs at many different areas, very broad, these bands are very broad, but also water vapor is very much saturated in all these areas. Only here you have a lot of small peaks that are not on the top already. And if we look at this absorption spectrum of CO2, we see that this broad line that actually makes the main absorption of CO2 is already saturated. And this is known to the Deutsche Bundestag, to the German parliament, already since 2020 by their own scientific service called the Wissenschaftliche Dienst. They published a special report on this fact. And the translation, it is in a version of 2023, but it's only the wording of other parts of this report were changed. This means that additional carbon dioxide entering the atmosphere will have no effect on the absorption in that portion of the band, that means this 15 micron band, because the carbon dioxide in the atmosphere already completely absorbs the wavelengths in this portion. And this is known to the German Bundestags since 2020. And to the IPCC, this is known since 1995. They had a special report of more than 380 pages where they say, at the center of the 5 micron band, that is this wide area, the increase in CO2 concentration has almost no effect. The CO2 absorption is indeed saturated at these wavelengths. That's something. You know it since 1995. Actually, the physicists that are working with spectra knew it even longer time. But this is officially in their report from 1995. And now we have looked at the individual gases, but in the atmosphere all these gases are mixed. So we now, from the same work, now we see here, we add ozone and oxygen, we get this absorption, we add the nitric oxide, and now we add methane. And I want to put your attention to this methane peak here, this absorption. If we go back, at exactly the same point there is an absorption peak of nitric oxide. And this nitric oxide roughly absorbs 70%, and this peak absorbs 80%, we cannot add this together. 70 plus 80 would give more than 100%, 150. We have to do a different calculation. We have to say, this absorbs 70%, therefore 30% are left, and from this 30%, 80% are absorbed by the methane. So all in all, 94% are absorbed, and only 6% go through. This is the combined effect of these two gases, and it is not, we can calculate it the other way around. For the light, it is completely indifferent to which gas absorbs it. Once it's absorbed, it's not in the light beam anymore. And if we add now CO2, we see this effect. And if we add water vapor, we see this strong effect of water. And this effect is called overlapping. You see here? If we now increase CO2 in the atmosphere, actually, since this peak is already nearly, or this band is already nearly saturated, we get a steeper edge here, we can add some of this white color will turn red. But on the other flange, nothing is happening because there's a lot, 100% of the incoming radiation at roughly 20 microns is already absorbed by water. And look, do you see any green anymore from methane? Yeah, here you see it. It is completely overlapped by water vapor. And now this is just the potential of the atmosphere to absorb light, and now we have to factor in at which wavelengths is actually light entering the atmosphere. And I showed this already to you. In this range here, nearly or hardly any light is entering. So this very strong absorption capacity of the atmosphere and also the methane, they don't add up to heat. It's not converted to heat because simply there is no light entering the atmosphere in this wavelength range. And the overall effect now is this. This is the light going into the atmosphere, and it is the light going through the atmosphere. And in all places where you see the white, there is light not present anymore. That is converted to heat, and you see this drop is from this peak here, from this oxygen peak, and these strong drops are from these water peaks. And here you see this white area, that is all of the light that does not exist anymore, therefore it's converted to heat. This comes from this huge water band, and on this side you have the combination of the water band and the CO2. This gives this very sharp drop here. And this one from the oxygen, you see this drop here. And now you can ask yourself again, what happens if we add CO2 to the atmosphere? More or less nothing. Where should it come from? If this peak becomes a little bit sharper, okay, first it is not much, it will become a little bit broader and sharper, but there is hardly any radiation entering the atmosphere, so the actual heating does not take place, simply because there is no radiation there. And also you see the nitric oxide, there's a strong peak here, it's a narrow peak but strong, but again this is in a range where there is no radiation entering the atmosphere, so the contribution of nitric oxide is zero, more or less zero. And if we ask the question, what would happen if we add more water vapor to the atmosphere? Okay, all these peaks will go up, not here, it is saturated, this is nearly saturated, but these peaks will go up. But here, we have the overlapping in the other way around between water vapor and CO2. So if these peaks go up further, there is already 100% of the light is absorbed and converted to heat by the CO2. So the only thing that is left is this water vapor peak and this water vapor peak. That means this one and this one. And if we add ozone, okay, this peak becomes a little bit higher. This becomes less light goes through, therefore it's converted into heat. And I let this now rest. You have to look at this. This explains the greenhouse effect. And this explains you the effect of the adding CO2 to the atmosphere. More or less nothing. There's nothing left, there's no process. Where should this extra heat come from? And that all the politicians should look at this graph. And I will present this graph in the Austrian Parliament. I'm invited to give a very short talk. And I will present in this graph. Where should the heating come from? There is no process. It's all saturated or overlapped. And this was investigated by a group of very good researchers very recently in 2000. Before I do that, I have shown you that the overall greenhouse effect gives a temperature increase of 33 degrees Celsius. And we can break this down. What is the contribution of water vapor? 29.4 degrees because of these huge blue areas that I showed you. The CO2 makes only 3.2 degrees Celsius. It's just this small part of red that you could see shine through. And the combined effect of methane and nitric oxide is negligible. It's 0.3 degrees Celsius. It's nothing. But the most important thing I have just picked this assessment report because from 2000 to 2022 we have already real-time data. Oh, there is a big problem. Because none of all these 152 scenarios really gave the real numbers. They were all warmer than the actual real data are. And there was last year, there was a climate scientist conference in Bratislava. And already for these climate scientists, they start already wondering, our models, they deviate a lot away from the real-time data. This is the real-time data. And you see how flat it actually is. And I make a prediction, a scenario. I just put a straight line through this data, and I come up with an increase of 1 degree Celsius. And my prediction is as good as theirs, because their computer models are completely wrong. They don't have the saturation effects in it. They don't have the cloud cover correctly in it. They don't have the negative feedbacks in it. They have much too high values for the positive feedbacks because it is dictated that they have to come up with some models that come up with that result in very high temperature increases. And what none of them has in is this dependence on the cosmic rays. And also I have not figured this out in my model, in my simple model, because what will happen in 2035? Nobody knows. But if Mrs. Sarkova is correct, you see a deep drop in temperature here. And it was very telling that their increases are quite smooth. It goes up like this. But we know there are a lot of oscillations. And it's also very telling to read the third assessment report, because there they tell the truth. They say the climate system is a coupled nonlinear chaotic system, and therefore no long-term prediction of the future exact climate state is possible. And there's another Nobel laureate called John Clauser. He's one of these three. And in May of 2023, he gave a speech in Korea to one of the universities, to the students, and he made the following statements. The popular narrative about climate change reflects a dangerous corruption of science that threatens world economy and the well-being of billions of people. Corruption of science. This is exactly what the statement before. They put a lot of money into so-called science, and a lot of institutes and scientists live from this money, but it's absolutely, like Mr. Clauser says, pseudoscience. It's absolute pseudoscience. It has nothing to do with science. They get grants for certain projects, so they deal only with certain problems. And most importantly, the results of the work is already predetermined, because if they come up with a different result, it is either not published or the funds are withdrawn. And I have a lot of climate scientists as friends in Austria, and they tell me, Bernhard, we are so happy that you give these talks. If we would give it, we will lose our jobs. This is really the reality. So nobody comes up with the reality. But Mr. Clauser came up, and the consequence was that all these institutions that invited him to have this Nobel Prize winner giving a talk, they cancelled all their invitations since he said that. So telling the truth is in a certain way not comfortable. Conclusions. In the history of the Earth, we are living in a rather cold period. The CO2 has almost no effect, even less on methane and nitric oxides. The greenhouse effect is very stable because of the saturation effects. So changing the concentration in greenhouse gases does not lead any big results. There are no tipping points. These are the mechanisms that lead to the change. Even though, and I stress it once more, the greenhouse effect is the strongest effect on the global temperature by itself, but it does not change. Human has almost no influence on this, and this is the important sentence. We always have been and we are climate neutral. We have no influence on the climate. No cent is necessary to reach climate neutrality because we are already climate neutral.